Hello everyone. Are you still applying for one of the top 10 companies? Are you ready for your technical interview? Do you know how to practice? Do you know how to ace the interview? Well, there is no one final and unique answer for that. What is sure and what I know is that you should be ready in terms of data structure and algorithm. You should practice well your algorithmic skill and data structure skill. You should know or try to know which data structure should be used in each exercise. Because behind the scene, there is thousands of candidates that are applying for the same position. They are all doing the same exercises. However, what will differentiate you is your structuring, your presentation of ideas, and your clear structure of working. That being said, let's stop talking and start acting. In today's video, we are going to solve one particular problem. The particularity that it has is the fact that it uses some special data structure that is really well asked and demanded in the software houses. Let's start together. So, what's the problem? It is a meeting rooms problem. We are given a 2D integer array of size n times 2, denoting time intervals of different meetings, where ai0 is equal to the start time of the ith meeting, ai1 is equal to the end time of the ith meeting. We have to find the minimum number of conference rooms required so that all meetings can be done. As usual, in the beginning it will be difficult to understand it. Sometimes it will be a new exercise for you. So what should you do? As usual, as we agreed previously, we should first start to elicit the requirement and to try to understand them more and more. So to do it, and to do so, we should ask for examples. In our case, let's ask the interviewer for an example. He will or she will give us A equal to 0:30 as a first meeting, so it starts at 0, it ends at 30. The second meeting, it starts at 5:10, it ends at 10. And the third meeting, it starts at 15 and it ends at 20. When we look at those three entries, we can see that there is one conflict. It is between the first meeting and the second meeting, because the first meeting starts at 0 and it ends at 30. However, the second one, it starts at 5. So the first conference room is already occupied by the first meeting. So automatically, when we look at that question, we understand that the expected output will be 2. So we will need 2 conference rooms. And this is how we got the value 2 in the previous example. That being said, now how to translate those ideas and this logic into the code? A way to do it is to check first what are the values that are being needed in the algorithm. So in our case, during each iteration, we are looking at the end date and the start date. The end date is being used as the availability date of the allocated meeting room. And the start date is being compared with the first available meeting room. To be more precise here, when we started with the 0:30, so the first meeting, we checked, is there any available meeting room? We saw that there is no. So what we did here, we allocated a meeting room and we stated that this meeting room will finish and will be available at 30. When we reach the second meeting and that starts at 5, we checked all the available meeting room. In our case, it is 30. We compared the start date with the availability date of this meeting room. So the 5 is lower than 30. So we will need an additional meeting room because the first meeting will not be over before the starting of the second one. So we allocated the new meeting room that will end and that will be available starting 10. When we reach the last meeting room that starts at 15, we checked what is the first available meeting room. We can see that the first available meeting room will be at 10. Since 15 is greater than 10, so we will be able to use that meeting room for our last meeting. In that way, we reach the solution. But there is a common behavior here. Each time we are checking the first available meeting room. And this first available meeting room has some logic, some priorities behind the scene, which is the first. So the one that has the least value. So the perfect data structure here is a priority queue. Interesting with priority queues is that the complexity is really not bad. So the insertion complexity is logarithmic. However, the access complexity is O of 1, which makes the algorithm really powerful. So after having explained the solution, let's jump into the implementation. So in terms of implementation, we should first discuss the contract with the interviewer. Since we are counting the number of meeting rooms needed, we can name the function number of meeting rooms. The return type will be an integer, and the function attribute argument will be a vector of pairs of int. We will call it meetings. In that example, I'm going to write the solution in C++. So first, we need a variable which will represent the meeting rooms. So the type will be priority queue of int. So priority queue of type int, meeting rooms. And after that, we need to iterate over the meetings. So for auto meeting in meetings, so for each meeting of the meetings, we need to get first the first available meeting room time. So we will take the top value of the meeting room's priority queue. So let's call the function first available meeting room time equal to meeting rooms.top. We compare that value with the meeting.first, so the start date of the current meeting. If the first available meeting room time is greater than the meeting.start.first, we need to push and to add a new meeting room because the current meeting room will be used during that time by the previous meeting. So meeting rooms.push meeting.second. Else, so in case first available meeting room time is lower than meeting.first, so this meeting room will be empty during that time, so we can use it. So to use it, we need first to pop it from our priority queue and repush again a new meeting room with the new end date. So we will do meeting room.pop and meeting rooms.push meeting.second. And since we are using C++, and since if the meeting priority queue is empty, and if we try to access the top value, it will throw an exception. So here we can do we can handle the first case in the beginning. If meeting rooms.empty, so it corresponds to the first case, we do meeting rooms.push meeting.second, and we do continue. So in that first statement, we are going to handle the first case, and in the other, it will handle all the other iteration. And at the end, we should return the meeting rooms.size. And that's all. During your interview, it is recommended also to try to play the scenarios that you got in the example with your algorithm. So for instance, in our case, if we take our previous example, which was which was 0, 30, 5, 10, and 15, 20. So if you take the first meeting, 0, 30, we will get into our first statement. So our meeting room's priority queue will contain 30 as a first value. We will then continue, and we will reach the second meeting, which has as a start date 5 and an end date 10. We will check the top value, so first available meeting room time from the priority queue. So meeting rooms.top, it will return 30. We will compare 30 with our meeting dot first, so which is 5. Since 30 is greater than 5, we need now to push a new meeting room, so we will do meeting rooms dot push meeting dot second, so it will be 10, and we will continue the iteration, and we will reach the last meeting, which has as a start date the 15 and end date 20. We will get the top value, which will be 10 in our case. We will compare 10 with meeting dot first. Since 10 is lower than 15, so the start date of the meeting, so we are going to reach the else statement. So in that situation, we are going to pop the 10 value from the priority queue, and we are going to push the end date of the last meeting, which is 20. And at the end, we will reach the return statement, and we will have in our meeting rooms the 30 and the 20. So the size will be 2, and we reach the expected value. And that's all for the solution. I hope it was clear for you. Don't hesitate to add, as usual, your comments. It's more than welcome. I hope you enjoyed, and see you soon in the next videos.